Our Dynamic Earth is an earth science unit incorporating ideas about patterns in Earth's surface features, how the Earth's surface is changed over time, and how these changes impact humans. Let's look into the unit at a glance. This unit covers several 5th grade earth science standards about patterns on Earth, stability and change of Earth's surface, and the effect of these changes on humans. The unit also covers several 3rd through 5th grade engineering standards about defining a design problem and generating solutions to the problem. Each of the next generation science standards correspond to a Missouri Learning Standard listed in parentheses on this chart. Take a moment to pause the video and review them. In this unit, students try to figure out patterns in earthquake hazards in the United States. The anchoring phenomena used to connect students to the science content is that some regions of our country are at higher risk of earthquakes than other places. They are promoted to ask questions to consider what causes these patterns to occur. After each lesson, students will reflect to consider what they have learned that will help them figure out the answers they have about earthquake risk in our country. The design challenge for this unit is a culminating activity in Lesson 7. Closely connected to the anchoring phenomena of patterns in earthquake hazards, students are tasked with designing structures that reduce the impact of earthquakes for humans. They will design, test, and refine a structure to resist the destructive power of earthquakes. Now that we have an idea about what students will study in this unit, take a look at the unit flowchart. This unit is divided into 3 sections, and there are 7 lessons total. Section 1 asks students to gather, analyze, and interpret map data to describe patterns in Earth's features. This section will take about 5 days. Here are some of the content-level big ideas for Section 1 and how students will figure them out. To begin with, students will analyze a variety of maps to determine their purpose and describe observable patterns. They figure out that maps have different purposes, show different features of Earth's surface, and depict how Earth's surface can change over time. Next, students use maps and interactive simulations to observe patterns in the location of mountains, ocean features, earthquakes, and plate boundaries in order to figure out that there are relationships between the location of Earth's features and the location of plate boundaries. They will revisit these patterns in Section 2 to provide evidence for processes that cause changes to Earth's features. Section 2 asks students to dive deeper to determine how patterns in Earth's surface are driven by interior and surface processes. These processes cause Earth's surface to change over time. Fossil evidence can be used to support these observations. This section will take about 10 days. Students develop fossil models to explain how fossils form in sedimentary rock layers and use a simulation to identify how patterns in the location of fossils on Earth can be used as evidence of changing Earth's landscapes. First, students will consider how Earth's interior processes affect Earth's features. Students will use plate tectonic simulations to develop explanations about the motion of Earth's plates and how this plate motion causes the patterns in Earth features that students observed in previous lessons. These changes to Earth's surface can occur so slowly that they cannot be observed directly. Next, students will consider how surface processes affect Earth's features. They will conduct investigations to explain how weathering and erosion by wind, water, and ice change landscapes. These changes to Earth's surface can occur over slow and fast timescales. Section 3 asks students to examine how Earth's surface and interior processes affect humans, and how we can use engineering design to minimize the impact of hazards that arise from these processes. This section will take about 6 days. Students use interactive maps to show patterns of Earth's processes that impact humans, such as earthquakes, tsunamis, volcanoes, and floods. They figure out that maps can be used to indicate locations on Earth that are at greatest risk of these hazards. However, predicting certain hazards like earthquakes with great precision is difficult. Because natural hazards like earthquakes cannot be prevented or easily predicted, humans design structures to minimize the damage they cause. Students will model this process by engaging in the engineering design cycle, developing a structure that can withstand a simulated earthquake. By the end of this unit, students will understand that our Earth is a dynamic system that changes over time. These changes are caused by interior and surface processes, including plate tectonics, weathering, and erosion. Humans are affected by Earth's changing surface and use engineering to mitigate damage caused by natural hazards. For more information, visit us at our website, myscipartners.com. mySci, inspiring the next generation of scientists.